Decimal or base 10 numbers can be converted to binary using a recursive process. Let's start by reviewing the layout of a decimal number versus the layout of a binary number. If we use the number 26 in decimal, it's actually represented by 2 of the tens column and 6 of the ones column, which makes 20 plus 6. Now the same number 26 in binary is actually 11010, which is 1 in the 16s column plus 1 in the 8s column plus 0 in the 4 column, 1 in the 2s, and 0 in the 1s. So if I add 16 plus 8 plus 2, I get 26. Notice the layout of the decimal table has 10 to the 0 power, which is our ones. Then it has 10 to the first, which we call the tens column, then the hundreds, thousands, etc. Every other base number has a similar notation, where it's 2 to the 0 is the ones column. That's always the first. It could be, if we're doing base 3, it would be 3 to the 0, which is equal to 1. Anything to the 0 power is 1. The next column, since I'm starting on the far right-hand side, the next column to the left is 2 to the first. So that represents the number of 2's in my number. Then I go to the next one to my left, and 2 squared is 4. And it keeps going. 2 cubed is 8, and 2 to the fourth is 16. So what we want to do is we want to be able to take a decimal number and convert it to a binary number using a recursive process. The process that we're going to use first starts by finding the remainder of the number that we started with divided by 2. This is going to be the value of the rightmost column. So we can see 26 divided by 2, the remainder is 0 because it goes in evenly. And we have a 0 in our first ones column. From there, we say, okay, take 26 and divide it by 2 and call the method again. Now the method says, okay, now I have the number 13. 13 mod 2, which is the same thing as saying find the remainder of dividing it by 2, is equal to a 1. So you'll notice that 2 to the first has a 1 in that column. And then I go ahead and take 13 divided by 2, which is 6. Remember, we're dealing with integers, so it ignores any decimal portion of the number. Now I do 6% sign 2. Again, an even number is going to give me a 0 remainder, and you'll see that 2 squared has a 0 in that column. Now I divide 6 by 2, and I get 3. I bring the 3 down. 3 remainder, or 3 mod 2, is equal to 1. So there's a 1 in the 8s column there. And I take 3 divided by 2, I get a 1. 1 mod 2 is equal to 1 because 1 divided by 2 has a remainder of 1. And then I take 1 and divide that by 2, and that's equal to the integer value of 0. And now I'm done. And you can see I now have the number 11010. So in this case, our base case, the quotient is 0, and our recursive case takes the original number divided by 2, and each time it reduces the number coming into our recursive method by dividing that number by 2, and then it prints the remainder. So in this case, what we're doing is we're trying to print everything that we need except for that last value. Again, that's kind of the way you want to think about this, is what is the base case. So printing all but the last bit is the same as printing the binary equivalent of n divided by 2. Okay, let's go over to NetBeans and see if we can set this function up using Java and Recursion. I'm going to close my Recursion examples folder because we're done with that. And I'm going to open up, I already have a project created called Decimal to Binary. The Java file is in your exercise files folder under 0201. Let me close my output window. I have the main method filled out for you because that's not really part of the recursive process. Let's look at it real quick. So in the main method, starting on line 19, I declare a scanner object so I can read a value from the user. I ask the user to enter a number between 1 and 100. On line 22, I just want to make sure they entered a valid value. So I say while in.hasNextInt. If it is a valid value, then I will go ahead and read that into my variable a. But if the value they entered is either less than 1 or greater than 100, I'm going to say invalid number, please try again, and I'll read in a new number. Line 30 is where I call my recursive method called printBinary, and I give it the number the user entered. Let me scroll down. Line 35 is the start of my method. private static void print binary, it comes in with just an integer b. First, I need to check my base case. So I want to start by saying if b is greater than 0. If it is, then I want to call my recursive function. So I'm going to say print binary, because this means I'm not at my base case yet. And I'm going to give it b divided by 2. So it's going to go back up and it's going to call the print binary again. Below that, I want to print out, actually I'm going to do a printf so I can format it a little bit. I'm going to use the $d for my number, comma, b, $2, because that will allow me to print the remainder of b divided by 2. Okay, at this point that's all I need for my program. So this will loop through until it gets to a point where the base case is b equals 0. In that case, it'll get out of the function. Since it's a void function, I don't have to have a return here, since we're actually printing the values. So it's a little bit different than the ones we saw before. Let's go ahead and run it, make sure it works. So we'll start with our number 26. So 26 is 11010. Awesome. So that looks like it worked. The way I have this set up is we can enter another number or Q to exit. Let's try one more. Let's say, what happens if I want to find the equivalent of the number 2? Remember, there's a 1's column, a 2's column, and a 4's column, so this should give me 10. And we get 10. It's not 10, it's 10. Remember, it's binary, so it's in base 2. Well, let's do one more. Let's try 28. 11100. Okay, it looks like it's working, and you can see if I scroll down, the amount of code in my recursive process is very small, so it did make this program pretty easy to understand. I'm just going to type Q to exit.